Well, my name is Luis Félix González Blázquez. I come from Universidad Carlos III in Madrid, and I'm here to present our most recent proof of concept that we submitted to OSM and has recently approved, where we leverage the OSM virtual networking in Kubernetes clusters. Now, before I start with the presentation, I want to say the whole team that we are here in Universidad Carlos III in Madrid, that we have worked for this proof of concept, which is Borja Nogales, Ivan Vidal, and Francisco Valera, and myself, Luis Félix González. We have all worked in this proof of concept that I hope that you will enjoy or at least find interesting to see. Now, before we start with the presentation of the proof of concept itself, to see how OSM leverages this virtual networking and to try to deploy a network service inside a Kubernetes cluster, we need to first check a little bit on how Kubernetes actually performs the connectivity of Kubernetes network functions inside a standard Kubernetes cluster. Because you know how Kubernetes works and the networking model that it imposes over Kubernetes cluster, usually all the functions, which in this case could be pods or a set of pods, are interconnected, all of them through CNI plugins that usually follow a flat networking approach, because Kubernetes imposes that all of the pods must be able to see each other at the IP layer level. So what we have in a Kubernetes cluster is something similar to what we can see on the screen, where all Kubernetes network functions are able to see each other at the IP level. And this is good for the high availability and for the exchange of application data. However, in our experience, especially with the deployment of network services using OSM, this is not necessary for the effective deployment of certain networking functionalities that can be found in many of the use cases that are used for the deployment of network services. This is the reason why, instead of having this flat networking approach, we want to have in Kubernetes cluster some solution or something that will allow us to create different virtual links between the Kubernetes network functions that are deployed over a Kubernetes cluster, just like we see in the image, with different virtual links that interconnect these Kubernetes network functions, or having these virtual networks that enable point-to-point or multi-point links that allow the Kubernetes network functions to interact with each other. This is the reason why it is necessary to have some solution that allows to have this kind of behavior inside Kubernetes cluster in order for us to start with the deployment of network services inside Kubernetes clusters. This is the reason why for this proof of concept, we have used the L2SM open source solution that we have presented in our meetings in OSM, which basically is a solution that provides complementary networking functionalities to the standard Kubernetes CNI approach by allowing to create OpenStack-like virtual networks managed by SDN. So inside the Kubernetes cluster, you can create different virtual networks inside a cluster and allow pods or different applications to attach to these networks, just like you would do in an OpenStack cluster, so that they're able to have this connectivity, this link layer connectivity, and to see each other, all the pods, all the applications that are deployed over a virtual network, just as if they were in the same broadcast domain or in the same LAN, which is very interesting for our purposes in order to have the tools in order to create these different virtual links for the deployment of network services. And if you want to take a look at the solution, you can scan the QR code that you have on the screen or visit the website that contains the solution and more details on this solution. But having this building block for us to have this connectivity allows us to now explore this virtual networking or deploy different functionalities inside a Kubernetes cluster through the use of OSM. And what we are doing in this proof of concept is to deploy a service that is based on a content delivery network scenario. And content delivery network, that it is very well known that you aim at closing let's imagine some content, for instance, multimedia content, to the users. So you would have some server that tries to retrieve content from a central server in order to close this content for the user so that it is easier for them to retrieve this concept. So what we are going to perform here is to deploy a network service to securely distribute all this media content over a Kubernetes infrastructure. And what the scenario that we have is the one that you can see on the screen, a Kubernetes cluster that has Kubernetes, of course, plus the L2SM Kubernetes operator to provide this virtual networking functionality. And then outside of the cluster, we have our open source MANO that can interact with a Helm repository in order to deploy all the different KNFs that we are going to have inside our Kubernetes scenario that we have on the screen. Now, going a little bit into more detail on what are the elements of this scenario, we first have a content server Kubernetes network function that is attached to a virtual network that we have here, a second virtual network. It is based on an engine server that hosts certain kinds of files. Any kind of file or a multimedia file is hosted, and then it will can be downloaded from within the cluster with the appropriate petitions. That the router firewall KNF is going to be in charge of securely distributing this request from, for instance, the CDN server that we are going to see now, in order to forward all the traffic, and then backwards, when the content server sends information to the CDN server securely through the virtual networks, then it is going to send that data using the router firewall KNF that we have deployed over the inside the Kubernetes cluster. And finally, a CDN server KNF that will be periodically try to retrieve these multimedia files in order to have, well, to store the file and then make it available for the users in the future, and through the use of an HTTP request. So this is what the network service that we are going to deploy inside the Kubernetes cluster through the use of open source MANO, and checking the ability of OSM to deploy all these different network services inside the Kubernetes cluster. So these are the steps that we are going to perform in order to deploy the network service and check that everything is working as expected. Now, for the first step, what it is necessary to do is one of the important aspects that this proof of concept provides, or some of the things that need to be seen in this proof of concept, because we need to create the virtual networks beforehand inside the Kubernetes cluster. Because although OSM has the tools to interact with a Helm repository for the deployment of any kind of Kubernetes resource, in reality it could be custom resource definitions, network attachment definitions, or any kind of resource in reality, it does not have the interfaces, let's say, to interact with these Helm charts or repositories in order to create the virtual networks that we have in the Kubernetes cluster, in the same way that it can see in other VIMs, like for instance OpenStack. That's why for this proof of concept, we have to perform this manually through the use of Helm. So what we do is create the virtual networks that are inside the cluster, which are the ones that can be seen on the image. And afterwards, once the networks have already been created, create the network service that we have defined over a descriptor, and then using OSM, we deploy all the different KNFs connected in the same way that that it's seen on the screen. After that, we need to check that everything is up and running and everything is working as expected. So what we do is retrieve a video from the content server, through the CDN server KNF, in the same way as you would do periodically get this video. So we start with the download of the video, checking that it is being received inside the CDN server KNF. So and then of course the router then will forward this request from the CDN server into the content server, and once the content server starts sending the video, then send it through the router, checking that everything is going through the middle KNF, which in this case is the router. Of course, we need to make sure that this is happening, and also it could happen that, because this is our Kubernetes cluster, it could happen that one of the nodes might be unavailable at some point, or one of the functionalities has turned offline. So what we're going to do in this case is to emulate that one of the KNFs has been turned off, in this case the router, because let's say from a node failure standpoint. So we scale the deployment to 0 and then wait a couple of seconds to check, to brought back this functionality online, in order to see that there would be a disruption in the service, and to check how it would react if the content would still be retrieved, which, because it is going through the KNF and we are transmitting the security, it should not until the KNF is already back and online, trying to retrieve the content. And once the link has been restored, it should start with the download, okay? So with this in mind, we are going to see a small video that showcases the deployment of this network service, and then how, and to perform some validation test to check that everything is working fine. So, of course, if you want to take a look at first to the descriptors, or at any moment in time, you can use the link that we have in the in the presentation so that you can check all the different descriptors and all the files that are necessary for the reproduction of this demo. And also, you can check the video as well if you're interested to after the presentation so that you have more time to see everything that we did. With that in mind, let me go to the video and let's start with the reproduction. Okay, so this is the presentation of the book. We will need to enter in our OSM machine through the GUI that is available for onboarding the descriptors that we are going to use for the deployment of this network service. Okay, so first of all, we need to upload all the different VNF packages. Okay, on these days, the Kubernetes network function descriptors. Okay, for the cache, the router, and the server that we have for storing having the video files and to have this scenario. Okay, so we proceed with the onboarding. This is the standard onboarding process that you can find in OSM, and then the network service, which we have the definition of the network service descriptor. Okay, so we start with the onboarding. You proceed with the onboarding and everything is working fine. Again, we have already seen the scenario that we're going to deploy, but this is the one. So now we are going to pre-create the two virtual networks that we have said before, because again, OSM for now does not have the interactivity itself so that it allows to create the virtual networks inside the cluster. It does have all the tools necessary, but not yet the interfaces that allow this behavior. So we create, using help, the different virtual networks. And as you can see, in our case, the network, which we are using with L2SM, is created inside the namespace that OSM is using for the deployment of the KNFs that we are going to put inside the cluster. Okay? And then we create the next network, which is the one. With this step, we have both of the virtual networks created in the cluster, and we can proceed with the deployment of the network service inside the Kubernetes cluster. So we go to the network service instances, and then we start with the creation, with the instantiation of the network service, okay? So now let's take the video so that it's able to introduce all the details of the network service that we are going to introduce, and then we proceed with the creation. And as you can see, it starts creating the network service, and then it will contact the Kubernetes cluster to deploy the different elements or different KNFs that are necessary for a network service. And as you can see, because they are in the running status, they are already deployed inside the cluster. We can check and go to the cluster itself and see that all the different pods composing the KNFs have been instantiated correctly, and they are on the running state in the namespace that OSM has assigned for the deployment of the network service. Okay, so now it seems that our service has been deployed successfully, but we need to check that everything is working as expected and that all the functionalities of the service are working properly. So we are going to access to the the cache Kubernetes network function and the content server Kubernetes network function in order to check that everything is working properly. So the first thing that we are going to do is to actually perform a ping to see that there's connectivity, as well as a trace route to see that they are going through the appropriate path. So in one of the KNFs, we are going to start with a TCP dump to check all the packets that are arriving inside the pod in this case, and then we start with the ping. And once we start with the ping, we should have connectivity, and as we can see, we have connectivity with the IP address that have been assigned in one of the virtual networks that we have. And then, in order to check that in reality we are going through the router KNF, we perform a trace route command. And as you can see, with the trace route, there's 2 hop distance, meaning that there's doing some routing in between, which our KNF is the one that it is doing in this case. So we see that this looks very good. So we are going to perform the download. And then we see that we are starting to retrieve the content from the content server that is KNF. And as you can see, everything is working fine. Seems that the video is being downloaded. And now we are going to emulate the failure of the router KNF because let's say that one of the nodes of the Kubernetes cluster has gone offline. So we start with this, and then the router KNF is offline. And as we can see, once the KNF was offline, the video stopped. stopped to being retrieved from the content server, and the download speed has gone to 0. Makes sense, because there's no packets going from one place to another because the router is currently offline. So there cannot be any connectivity. There cannot be any connectivity through the virtual networks that we wanted to have. So now we are going to bring back online the router to check that everything is working as expected. So, okay, we put the replica still on, and then we need to wait a little bit in order to make the service available, because it will need to perform to put online the KNF, as well as to perform all the different, start the container and everything in this case. So we let it wait a bit, and then we see that now the packets are being generated again, and the download can be resumed. You can see, so once the router was enabled already, then the download speed increases again, seeing that then we have the connectivity and the cache is able to download the files correctly. Okay. Again, this video is available as part of the proof of concept. So if you want to take a more in-depth look afterwards and everything, you have it available already, and you should be able to access it without problems. Okay. So now let's. From the experimentation that we have performed in this part, we can see some of the validation results that we have seen in this proof of concept. Is that performing the ping and the traceroute commands between the CDN server KNF and the content server KNF provide us that there is connectivity through the virtual networks that we have deployed the network services through the use of OSM, and also that the traceroute command shows that it is actually performing two hops between one of the KNFs to the other, providing us with these virtual links that we want to have inside the Kubernetes cluster for the deployment of network services. Not only that, but also that if one of the Kubernetes network functions that we were using for retrieving the video that we can see, all this traffic is video that is being retrieved by the CDN cache. Okay, once the router KNF is offline, then there's no traffic because there's no routing possible and the data is not being transmitted from one place to another. However, once it is brought back online, the service starts to recover and then proceed to send the data again, providing us with the expected behavior and the one that we wanted to have in this case for the deployment of this network service. So overall, we see that OSM has all the tools for the deployment of these different network services inside Kubernetes clusters, especially once there is a solution that allows the creation of these virtual links in the Kubernetes cluster that provides that tool to allow the creation of these links between functions. Then it is able to have these deployments. However, there's still a lack of interactivity between the OSM and the cluster for the creation of these different virtual links. But all the tools and all the support is already present because it can, for instance, interact with Helm repositories. So if any resource can be deployed inside the Kubernetes cluster, OSM should be able to perform this. This is the reason why we proposed a feature for the connectivity among cloud network functions or Kubernetes network functions used through the use of SDN. And it was already approved, and it's something that we are currently in the design phase of the feature. And so if you want to take a more in-depth look of the feature, that it talks a little bit of everything that we have talked in this today, you can take a look in the feature GitLab that is available, and the number is 1091. Okay, so just for wrapping up this presentation, these are the main key takeaways that have come from this proof of concept. Is that this proof of concept demonstrates that with a set of adaptations, then OSM is able to manage virtual networks inside Kubernetes cluster because it already has all the tools and all the necessary measurements in order to perform this. So with this in mind, with this change, it would satisfy the connectivity requirements of network services composed by different Kubernetes network functions. And of course, this proof of concept has detailed the different steps involved in the deployment of a network service. And the insight of this proof of concept will also assist in the assisting addressing the issue that appears from the deployment of these different network services inside Kubernetes clusters. So the OSM community is addressing already this problem with the design and implementation of a feature that will allow the connectivity of these KNFs through the use of SDN technologies. And of course, all of this proof of concept has been performed with open source technologies, mainly OSM, Kubernetes Helm, and L2SM. Now, these are all the different research projects that have been involved in this proof of concept, either because of the use of OSM for the deployment of different virtual functions, as well as with the use of L2SM for the establishment of virtual networks inside Kubernetes cluster, which in this case are the Horizon 2020 Labyrinth project, as well as the Horizon 2020 Fishy project, and finally the True 5G project from the Spanish National Research Agency. Finally, if you want some references or some documentation of the proof of concept that we have performed, you can take a look at all of the sources that we have used and some of the papers that we perform, as well as some of the links that we have used in this proof of concept. Nonetheless, this was everything from my side. Thank you so much for your attention. And if you have any questions, please do not hesitate to ask.
Yeah, hello, Luis. I would like to through you a question, because could you repeat again why can we use network services onboarded in OSM to create these networks? Because you mentioned that although it's possible, you were doing it manually.
Yeah, we have to perform it manually because right now there is no support for the creation of these virtual networks themselves through the use of OSM. It can be done, for instance, from the creation of Kubernetes network function descriptor. But right now, there's no interface that allows the creation of the network itself, like it can be done, for instance, in OpenStack. Like, for example, defining a network service descriptor. I want to create this virtual network that interconnects this network with this network because because Kubernetes does not support that behavior by default. So that's why there is not this behavior right now, although it is being addressed in the feature that we propose for the implementation in OSM and currently is under the design phase.
I see, but couldn't be that done, for instance, creating a Helm chart containing network attachment definitions, and from OSM we instantiate that network service, and by the use of the instantiation parameters, we could tweak these parameters, for instance, setting the interface type or the interface VLAN, whatever.
Yeah, that is one of the how to say this. This is one of the orientations that we are currently managing for the implementation of this feature. But what we want to have is not to have to perform this manually, but rather to have OSM be able to define define all these different values and to be aware that it is using for instance, these custom resource definitions that are inside the Kubernetes cluster, allowing OSM to actually pass these values at the instantiation level, for instance, so that it is able to dynamically create these virtual links rather than having them pre-created already inside the cluster.
Exactly, I see. So I'm doing a kind of a mapping between the network service descriptor and this network attachment definition directly from the descriptor, isn't it?
Yeah.
Okay. And how your tool, this L2 manager, will work?
This L2SM, basically what it provides is different network attachment definitions. They are defined as network attachment definition, and it creates virtual networks that other pods are able to introduce as standard network attachment definition annotations. But then we have an operator inside the Kubernetes cluster that allows the attachment of these different to these different network attachment definitions that define these virtual networks, and then the operator is able to pick up these different events and then to associate pods with virtual networks, and then through the use of SDN, then being able to connect the pods that are only in that virtual network itself, only allowing that connection and provide that isolation. This is in principle what the L2SM operator does. But there's more information about this in the GitHub that we have available, and the solution, as well as in the paper that we published in IEEE networks if you want to have more information about this. But basically, what it does is that it doesn't mean that the feature has to be 100% with L2SM. Of course, if it can be mapped to any other solution that perhaps enables this virtual networking, then the feature should be able to have that as well. But we use L2SM because it's a tool that we have used, and we know that it provides this behavior.
Okay. But thanks very much. Very clear for the answer.
Luis, this is Gerardo. Just pretty quickly, because we are right now above the time. Just to make a comment, as Adrian was mentioning, I think that the main point here is that it's possible today to deploy, let's say, networks or doing some kind of networking Kubernetes by modeling this with a CNF that is encapsulating that. I think that the main point of your comment and the work that is that you guys are doing with this new feature is to be able to do the creation of that networking as a kind of first-class citizen directly from a, let's say, virtual link descriptor in OSM. Okay, so that we don't need, let's say, the end user to provide the packages for that, so that they could be done as part of the, let's say, management of the cluster and also the creation of those links directly from OSM, right?
Mm-hmm. Yes.
Yeah, I would like to invite you, by the way, if you are interested in this feature and this work, okay, we are having tomorrow a session in the tech call. So if you have registered you can register to the technical sessions, and that we have tomorrow, and we will have a discussion about that also tomorrow.
Mm-hmm. Okay, perfect.
Okay, thanks for the answers. Really interesting presentation, Luis.
Thank you so much.